Okay, we're going to go over pages 100 to 109. They are the probability section 2, which covers the binomial and all of that kind of stuff. So we had the other day done number 1. We had gone over that in our notes and such. So we'll take, here is the information on that. Remember that we want it greater than 1. So since we wanted 2 up to 30, since that's what we wanted, then we had taken off 0 and 1. So we did 1 minus that bottom part. Now, I'm going to keep in mind if you showed work, then on AP you would show this formula of going from 2 successes up to 30 successes. And so that's how your work would look. All right, number 2. Number 2 just asks for the mean of x, and of course that is this formula, n times p. This information in the problem here was given to you so that you could extract from that what the n is and what the probability of success is. And that's how you get 4.5 for your expected value. Remember, expected value is the same thing as mean. Here on number 3, the average number of successes in a trial is this formula here. No, this is the standard deviation. The standard deviation for the number is that. The probability of failure for any given trial is this 1 minus p, and the probability that there will be exactly 2. No fraction stuff going on. It's written this way with n choose 2. So that was 2 only. Next, number 4. Okay, so in fact, let me go ahead and pull up the formula chart real quick just to remind you where these formulas are on what we're doing here. So let's see if we can pull that up. All right, so remember that when we're taking a look at this formula chart, we're dealing with these ones down here. These here are for the number of items. Okay, so this was the mean and the standard deviation for the number of items. And so that's what we're dealing with on this next problem. It asked for the standard deviation for the number of successes. Exactly 1. Again, this is given to you so you can extract from it the value of n and the value of p, probability of success. All right, on this number 5, this is very interesting. It says, what is the probability of failure on the 4th trial? So it straight up did not give any indication of the information before the 4th trial. It only asked about that isolated incident of the 4th trial. If it had wanted the information before, here's the way that question would have been worded. What's the probability that the first failure occurs on the 4th trial? Okay, that one then would have included your 0.2 times, or to the 3rd power times the 0.8. All right, now number 6 is very interesting, and it throws a little kink in the mix here. So let's take a look at what's going on. So a sample size of 8. So be aware that this is a too small sample size to be able to say that the sampling distribution is normally distributed, especially since they explicitly stated that the population shape is unknown. So that's your warning right there. Now, if that had not been the issue, then A would have been the appropriate answer because you have your x is smaller than 20. So you got your x of 20 minus the mean of 27. It says the mean of the population is 27 over the standard deviation. Okay, so let's recall from our formula chart that for sample means, our standard deviation was this standard deviation over the square root of n. That is why this is 8.5 over the square root of 8. So that would be the appropriate formula if we knew that the population was normally distributed, because then the small sample size would not be a problem. You know, we can take a look at what the issue was on these other ones here, and we can see that the second one, let's see if I can pull this down here. The second one uses the wrong standard deviation. The third one switches the mean and this x value. This one has both of them wrong. Okay, but here is the answer. The probability cannot be determined using the typical methods since the shape of this sampling distribution of samples of size 8 is unknown. Okay. All right, so that went through a little trick in there. All right, moving on to this one. Here we wanted to estimate the probability more than 20. Now, here's the thing that people were wondering about. We wanted to know which is the best estimate that the probability that more than 20 are failures. So, essentially, what I'm doing is think of a failure. Failure is what you want. What you want. So that means I'm putting this failure probability as this quote-unquote success, what I want. That's the key on this one. So I want from 21, so if I was showing work, I want from 21 up to 31 things that I want. And what I want is failures. So that's why 0.45 is that probability right there. All right, so calculator-wise, if I want 21 up to 31, then I do not want the bottom 20. So that is what I will take off. So that is why, calculator-wise, it's 1 minus the accumulation, 31, comma 0.45, take off the bottom 20. There's how you get your answer. Now, this was kind of tricky. This was, the misleading, I think, in a sense. The answer is 0.00898. And so, your eye is drawn to this answer choice D. But it's not that. It's rounded to 0.01. All right. Number 8. These are great because they make you analyze what the work is shown. We want 80 to 100, so take off the bottom 79. So we're either looking for 80 to 100 or 1, take off the bottom 79. And that's what A does. Okay, B and C mean the same thing. This one takes off the bottom 80. We don't want to take off the bottom 80. This one is 81 to 100. D is just the bottom 80. And E is just the bottom 79. All right, number 9. What are the mean of X and the standard deviation of X? So once again, this is the mean and standard deviation for the number of items. So you just follow those formulas and plug in the information. All right. Let's see here. Now, do be mindful. It tells us the failure rate is 0.4, and we wanted to know the success of an event. So we had to turn it around and use the success probability here. Okay, so you got to keep that straight when you're putting in those percentages. Number 10. All right, so this one is giving you this information here so that you can identify the probability of success. And again, it says, what's the probability of success on the first trial? So just boom, what's the probability of success? And it's A. So again, essentially identifying, do you understand what this formula format is telling you? Okay, number 11, just fill in the formula. Do not evaluate, just fill it in. So the question was asking, out of 40 trials, that's N is 40, you want exactly K successes, and that is 17 successes. Probability of success is 0.3. So straight up filling in the formula. So there we go. And next, number 12. Okay, so the probability of failure is 0.2. So we are wanting the success rate. We want exactly 10 successes. X is the number of successes. That's what it tells us right here. And so X is the number of successes. So we want exactly 10 successes. Okay. So you keep that straight. That's how we knew we wanted the successes, not the failures. It defined X as successes. All right, moving on. Number 13. Okay, this was another one. We want exactly 5. So probability that you have exactly 5 is 16 choose 5. So here is the formula, AP formula that you would have to show. And your answer is 0.12. Okay, number 14. Straight up just, again, asks you only about the 4th trial. It doesn't ask for you to know anything else, just the occurrence of a success on the 4th trial if failure is 0.3. If failure is 0.3, then success is 0.7. Okay, now number 15. I've seen some problems with this one. People are so ingrained to do 1 minus, but I want you to keep in mind, if you do 1 minus, then you will get an upper probability. Okay, so if we're going to 23. This problem says that what you want is fewer than 3, which means you want 0, 1, and 2. So you are just accumulating 0, 1, and 2. No need to do 1 minus, because if you do 1 minus, you're going to get the upper part, but you just want the bottom part. Notice if you were an AP student or AP free response, this is the work you would want. The first amount of successes is 0 up to 2 successes. All right. Next, here we go. This is, again, turning a binomial problem into estimating it with the normal model. Okay, so you can see that it asks you for fewer than 200. So if you were to do this the binomial way, then you would go from 0 successes up to 199 successes. And so this should be the work you are looking for if this was done in a binomial way. All right? And none of the options are there for that. A and B just give you exactly 200 successes or exactly 199 successes. All right, so then that means we're out of luck there, and we need to do the normal approximation because that's our only options that are left. So if we're going to do the normal approximation, then we need x minus the mean over the standard deviation. And in order to do that, I know 200 is my x, and I need my mean for the number of items. See, these are in terms of number of items. This is in terms, standard deviation, in terms of number of items. 200 is the number of positive reviews. Okay? So here we go. With the normal approximation, you would do the formula for number of items right here. Mean of x and standard deviation of x. Once you get those, you fill it in. You can see D is wrong because it puts the wrong number here. That is not N. 200 is not the correct N. And here in part E, they switched the mean and the x value, so that's what's wrong with E. C is the correct formula for the normal approximation of this binomial situation. All right. You know, I want to take just a second. Let me talk to you about why I say this is a binomial situation. Because if I'm thinking about number of employees that received a positive review, then, you know, technically that's a discrete amount. You know, you're going to have just 199 or 198 or 197 or whatever positive reviews. So technically, this is a discrete situation, and so a binomial probably is more appropriate. But so often, you know, since we say, oh, it's a large sample of over 300, so I can approximate it with the normal model. So then you can do a normal approximation to that. So that's why sometimes those things get combined together. All right, now number 17. Which one of the following statements is not true? So let me tell you, with D, they're all true except for D, and here's why people get mixed up with D. D says its shape will be approximately normal if more than 30 samples are found. Okay, guys, that is saying you just have more than 30 of these little X bars filled in this shape. No, this is infinite amount of sample means. The key is that this X bar comes from averaging more than 30 items. Averaging more than 30 items, and that's that X bar. Averaging more than 30 items. It's the sample size that has to be greater than or equal to 30, not just more than 30 means. The size of what was averaged together to get those means has to be greater than or equal to 30. All right, and number 18 is again a binomial PDF because it's 20 having exactly 8 successes. So those are pretty straightforward. Now look at number 19. You know, this should be this is a dead giveaway. You know, I think this is awfully nice of this to be kind of, you know, warned to you, because on AP, I don't think they would straight up do that. They would just say a population has a mean of 25 and a standard deviation of 3.4, and then just leave out whether or not, you know, what the shape is. And then you have to go, whoa, this is only a sample of size 16, and they do not tell me it's normally distributed, so I do not know. So the mean and standard deviation cannot be found since the sample size is too small. All right, so that mean and standard deviation cannot be found since the sample size is small. You know, I will double check this. I think that you still can say, so I need to double check this, okay? So here we go. Tomorrow, then I will get with you and let you know. I think we can still say what the mean and standard deviation is, you know, via our formula chart. We know that our mean and standard deviation are going to be dealt with this way. So I think mean and standard deviation can still be identified. It's the shape that is unknown. So let me get back with you on that one, and we'll discuss that before you take your quiz tomorrow. All right, number 20. Here is another binomial one. Just want to do the mean and standard deviation for the number of items. Fill in the formula. Number 21. Let's see here. Oh, looky there. We did have a sample size that was 60, so our shape or the size of our situation was covered. But Now look here. Look here. This is so not even right. Look at my bad right here, what I did. That is not right. This is a proportion problem. So what's the quote-unquote large enough for proportions? Our large enough for proportions has to be such that NP is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. Okay, so we want to check those, and so I know here that 80% of 60 is going to be, you know, something there that I'm not doing in my head. Was it at 48? 48. Okay, so 48 successes, and then 20% of 60, that will be the remainder of those, which is 12. And so both of those are greater than or equal to 10. So that's not, it's not because it's greater than 30, it's because NP and N times 1 minus P are both greater than or equal to 10 that we're going to be dealing with the approximately normal. Okay, so watch out for that. Proportions versus mean. Look at there, I fell for that. All right, moving on. Number 22. This one was just straightforward. This one actually is considered geometric. See how this is worded. The first success occurs on the fourth trial. So it specifically defines not a success, not a success, not a success, success. So that's when it's geometric. It doesn't occur until the fourth trial. That is geometric, okay? So you can do that. Now, if you were to do this in your calculator, by the way, this would be geometric. If you were interested in doing this in your calculator, you don't have to. PDF of P, and then where you of the 0.37. I want the 0.37 to occur in the fourth spot for the first time. Okay. Now I've gotten people asking me, what's this geometric CDF stuff? So, you know, if your brain is ready to absorb this, let me kind of tell you. Geometric CDF, by the way, that would be this kind of wording. The success occurs on or before the fourth trial. Okay, see, so you're accumulating the possible locations of a success. It can occur on the fourth trial or before, on or before, accumulating the places. That's when you would do geometric CDF. All right, moving on. So 23, there's the mean and standard deviation. There you go. We've got that going on. It is a mean problem, and we've got a N of 150, so straightforward formula. All right, and then number 24, or means to add. So we have a success on the 10th spot or on the 11th spot. So this is basically, do this kind of by hand. Here it is occurring in the 10th spot and then on the 11th spot. See, technically they show this out of order. I mean, here's the order if you were interested in. 9 failures and then a success. And see over here, they're just showing you the commutative property of multiplication. You got your 9 failures and then you got a success. All right, and then this next one, 10 failures. So you have 10.3s and then you got your success. And you're adding those together because of or 10th success or 11th success on the 11th. Okay, and this one's the same way. It's occurring, you know, the success is happening right off the bat, which means there were no failures. Or it's happening, there was 1 failure and then the success. All right, so that's the first or the second trial. Okay, so that's the end of that. Now, we did the pages 110 and 111 yesterday during class, and so I have the next video that I have is going to go over the frappies on pages 110 and 111. Okay, but homework-wise, I want you to do the two problems that we have passed, and they're in the beginning of your packet, or not beginning, but they're out of order. So I want you to do for homework pages 86 and 87. It's two more free responses. Be aware that you know, the packet in that section, it's like out of order, pages 83, 84, 85, 86. So be aware it's out of order, so you need to go hunt in the 80s for pages 86 and 87. So that's what I want you to do. But now I'm going to have the video for the free responses on page 110 and 111 to go over.